Hello everyone, welcome to another learning session. Today we will learn about Azure networking. We will actually get started with Azure networking, which is one of the core services within Azure cloud. But do not worry, we will start from the very basics. I had shared prerequisites for the course as a whole and also prerequisites for this particular session. Can you all tell me frankly how many of you have gone through the prerequisites for the Forum CA course as a whole, or at least prerequisites for this particular session? You can be frank. If everybody has gone through everything, then I don't have to explain it again. Otherwise, I will briefly explain what is needed for this session and then we can get started. Can you quickly confirm in the chat? If you have covered the whole prerequisites for the course, you can just type W at least for this session. You can say P, and if you have not gone through any prerequisites at all, you can simply say N. Okay, good. Majority of you have gone through the complete prerequisites, and few of you have gone through partial prerequisites. Okay, somebody had mentioned, okay, not sure if there was any specific prerequisites for this session. It was shared in the invite. The ones that are specific for this session were shared in the invite. The invite that was sent earlier and the remainder that was sent today all had the same prerequisites. So I'll briefly talk about few things. If you have any doubts, do let me know. Okay. So when you consider Azure Cloud, assuming you are completely new to Azure Cloud, whenever you buy some software, you will need to buy a subscription, right? Basically, you will need to pay for that software as a service on internet or on cloud, whatever you want to call. And that billing happens through a subscription in Azure Cloud. When you consider other cloud such as AWS, when you create an account, your billing is associated with an account. But here, when you create an account, actually a tenant is created. Tenant is your company's identity on cloud. For example, if you have a company ABC or let us say Buddy Tutor, so Buddy Tutor will have an identity or tenant on cloud, and it will be associated with multiple Microsoft SaaS services. So Azure Cloud is just one of them. Okay, Azure Cloud is just one of them. You will have Office mails, right? The Microsoft 365 mails. So that is another. So everybody shares this one single tenant. And when it comes to Azure Cloud in specific, you have something called as Azure subscription, and you create your resources such as virtual machines or virtual networks, the kind of resource that we are going to learn today. All of these things you create within this subscription. So Microsoft will be billing you through these subscriptions. You can have more than one subscription. For example, if a company need different billing for different departments, they can create different subscriptions for different departments. There are other ways through which we can do that even with a subscription using cost management, using tags. Once you attend all the sessions within the Forum CA program, you'll be clear about all of these things. Coming to Forum CA primarily focuses on Azure Administrator syllabus or the AZ 104 syllabus, but I felt like whenever people went to interviews after these, they were actually not asked questions only from the AZ 104 syllabus, but they had questions from identity, which is SC 300, and also AZ 700, which is networking. So, apart from this 104 syllabus, we will look into important topics from SC 300 as well as AZ 700 in future sessions. And one more thing, Microsoft has designed the AZ 104 certification not as a beginner's guide. So this is the associate level, the second level. So Microsoft assumes that okay, you have some kind of working experience with Azure Cloud, so that you are familiar with all of these services, and you are here to learn deeper about it and to take the AZ 104 certification. Because of that, this particular certification AZ 104 covers different topics. For example, module 1 is about identity. And if you want to continue learning, then you have SC 300 for complete identity. Module 2 is about access management. Module 3 is about administration. Module 4, 5, 6 are about networking. And module 7 is about storage. Module 8 and 9 are about compute options. And module 10 is about backup. Module 11 is about monitoring. So as long as you are starting with a topic and you have a basic knowledge, you should be able to start with any of these different topics. But some of them will have some prerequisites. For example, you can start with module 1. That is perfectly fine. You can start with module 4. That is also fine. But if you start with module 5, it will not work out well because that is within a topic, within the topic of networking. So you have to start with module 4 or watch module 4 recording before going to module 5. So you can start with any of these major topics, but subtopics will be challenging. Similarly, if you go to backup and monitoring, you will need some knowledge of the services covered before that. So again, directly jumping to backup or monitoring may not be ideal. So you can start with module 1 or 2 or 3 or 4, and then you can start with either module 7 or 8. That is my recommendation. When it comes to a cloud is something that is outside our on premises or outside our system, right? And there is a big network between us and the cloud, which is the internet. And within cloud, we can create our own isolated networks called as virtual networks. Okay, so before going to that, let me ask you one thing. So, irrespective of where you are from, whether you are from Canada or India or US or Australia or any place, you will see houses, buildings, offices, lot of things around, right? If somebody wants to send a mail to any of these buildings or houses, how will they send the mail and how does the mail reaches them? So they will have a address, right? They will have a physical address. Similarly, in case of cloud, in case of any device on the internet, you will need an IP address. Okay, IP address is something like 192.200.300, something of that kind. So we will learn in detail today. So some numerical thing just to get started. That numerical address will identify that device. That is IP address. And imagine you will have to remember all these IP addresses like 192, 128 for reaching any of these websites. For example, imagine what is easier to remember buddytutor.com or to remember 192.168. Some number. And that conversion is called as DNS, domain name system. So we'll not be covering the whole of virtual networks today. DNS we will cover in the next class, and I'll definitely share the required prerequisites before that. But today, let us try to understand how virtual networks can be designed and how IP addresses fits into all of these things. Yeah, there is a question. Please consider I have no knowledge about subnets, IP addresses, assignment. Yeah, I always assume that it is fine. So in case if you missed prerequisite, the only thing you have to do is if you are not able to understand anything, just ask. So that is the beauty of live sessions, right? You can ask doubts. With the recording, you cannot do that. So I'll make sure that even if you have not watched it, you will still understand every single thing that we discuss in this class. Can you all confirm if you can see my screen? Because unlike other sessions where we can discuss through presentations or Azure Cloud Portal, we need to make sure we have a clear understanding of IP addresses before proceeding with virtual networks. Tell me one thing. What are the different kinds of IP addresses? How many of you are aware about IPv4 versus IPv6? Yes, public and private is also another categorization. We will look into it. Yes, we will look into static and dynamic. We will look into private and public. So to start with the very basics, how many of you are aware about IPv4 and IPv6? Since we have a few people who are unaware about it, it is very simple. IPv4 means the IP address will have 32 bits. And with this, we could cover a lot of devices when internet started. But later, when the internet grew into something much bigger as we see today, and which is still growing, the IPv4 addresses became less and less available. So that is where IPv6 was introduced with 128 bits. And I don't think it will get over anytime soon. Another thing that happened in parallel was that, so rather than giving a public IP address from this list to all the devices, including devices at home or including devices at offices, including devices on cloud, and all those devices which are not actually connected to the internet, researchers came up with the idea of private IP addresses. So there are few ranges of private IP addresses. So you cannot connect to internet using private IP addresses, but within an organization or within your home network or within a cloud, you can use three different ranges. So we saw that also in the video. And when we create a virtual network on Azure Cloud, we'll be using one of these private IP address ranges. And whenever we want to connect to internet or make our service available on the internet, basically if people want to connect to our service through an IP address, then we will allocate public IP address to that particular virtual machine. Clear until now? Let us take this 32. So once you understand the concepts with any of these, you can apply the same for the other one also. So let us consider 32 because it is easy. And here you will have total 32 bits. and it is divided into four parts, four equal parts. So part 1 dot part 2 dot part 3 dot part 4. So this is how INI IP address look, right? So it will be 192 dot 168 dot 7 dot 0, any such combination. And how many of you know about binary versus decimal numbers? This is just pure mathematics. Please excuse me for my handwriting. If you are not able to read anything, you can let me know. How many of you are aware about binary versus decimal? If you are not aware, you can simply say no. From a programmatic perspective, okay, binary means true or false. Decimal means integers or floats. I'm asking about the bits and bytes within your computer, the lowest level of representation of data. So you know, right? So everything is represented as zeros or ones within your computer. So binary means it is either 0 or 1. So you have a decimal 1 and corresponding to decimal 1, what is the binary? It is 1. And corresponding to a decimal 2, what is the binary? Yes, 1 0. And corresponding to 3, 1 1. And so on. 4 will be 1 0 0 and so on. So here, each of these are represented by binary, and the total number of binary bits are 32. So tell me how many bits will be there in each of these parts. Very simple mathematical question. Yes, it will be 8. So here it will be 8 bits, here it will be 8 bits, here it will be 8 bits, and here it will be 8 bits. Total it will be 32 bits. So now tell me, what is the minimum number I can have here? That is a very, very straightforward, dumb question. What is the minimum number I can have here? Tell me, what is the minimum number I can have with 8 bits? As I mentioned, it is a very, very simple, dumb question. And interestingly, nobody answered it at all. It is 0. Minimum is 0, right? Am I right or am I right? Can you give some confirmation? So minimum is 0. And what is the maximum? Some of you mentioned maximum when I asked for minimum. So there are 256 possible combinations with 8 bits. But since we start from 0, the maximum possible is 255. So if we had started from 1, then it would be 256. And how is this 256 calculated? So if you have 8 bits, then you can calculate as 2 raised to 8. So 2 raised to 8 is 256. And since we start from 0, the maximum is 255. Clear until now? We can take time to digest these things, because once you understand these concepts, how to create a VNet on cloud, or how to add a subnet, all of these things are there in our recipes, right? So even if you miss the session also, if you just follow our recipes, you can learn all of those things. Okay, so there is a question. So 8 decimal translated to 255 binary. Yes. So that is why I showed you this table, right? Okay, so if you continue this table and corresponding to 255 on left side, you will have 1 1 1 1 1 1 1 on the right side. So because this is the maximum number I can have with 8 bits, right? All ones. And minimum number is all zeros. Clear? And you can use any calculator for these conversions. If you're interested, I can talk about the mathematical conversion behind the scenes, but you can use any calculator. But have you understood why this correlation? Good. So you are clear about minimum, maximum. So the maximum IP address that we can have is 255.255.255.255. Okay. So now when you consider a network, let us consider our virtual network. So what is a virtual network? Virtual network is just a isolated network within our cloud. Azure cloud, AWS cloud, Google cloud, all the cloud providers have the same concept. And when you create a virtual network, you assign a set of private IP addresses to that virtual network. So imagine that we have 256 IP addresses, or maybe we have 65,000 IP addresses. So is it practically possible to list down all of those IP addresses that are part of a network? No. So that is where we have a notation called as a CIDR notation. Previously, we had this concept of dividing as a class A, class B, etc. That is no more used. CIDR is a symbol notation. If you have an IP address, say 10.0.0.0, you simply add slash and a number to it, say slash 24. So what does this slash 24 denote? All of you said, or most of you said you have gone through the prerequisite discussions, so you should be able to answer it. What does this slash 24 denote? If you don't answer, I will still explain, but I want you to try. Today's session, I want you to try. Just be very, very active. Try. It is perfectly fine if you make mistakes. Yes. So when you have an IP address, so we told, right? So it is bits. All the bits are not used for allocating IP addresses to your machines. It could be physical machines or virtual machines. So how do you divide it? So the initial part, so initial bits, some of the initial bits will be used for identifying that virtual network. Okay, so some of the bits will be used to identify that virtual network, and within that virtual network, some of the bits will be used to identify a subnet. So we'll learn about subnet shortly. And so those bits that are used to identify a virtual network, it is called as network identifier bits, and the remaining is called as host identifier bits. So here, if I say slash 24, I am saying that 24 bits are used for identifying the network, and remainder can be used for identifying virtual machines or physical machines, whatever machines are allocated within that network. So the remaining are called as host identifier bits, and the initial ones are called as network identifier bits. So when I say slash 24, network identifier bits are 24. So can you tell me how many host identifier bits are here? Everybody try to answer. So if you really try to answer and be active in today's class, whole of your Azure Cloud journey with respect to virtual networks will be very, very easy. Yes, it will be 8. How? It will be 32 minus 24 and it will be 8. And now tell me, in this IP address range 10.0.0.0/24, how many devices I can allocate IP addresses or how many hosts I can have. So there are 8 bits, right? So do not worry about like usable bits or unusable bits that are specific to a provider. Like a cloud provider may have some bits usable, some bits unusable. But when you learn IP address mathematics, it doesn't matter. Let us go from the very basics. Okay, so here I have 8 bits available, right? So how many machines I can allocate or how many hosts I can allocate? It is 256. How did I derive on it? It is 2 to the power of 8, which is 256. When it get converted to bits, binary conversion, it will be 0 to 255. We already saw this part, right? There are 256 addresses and then you will allocate it as 0 to 255. I'm trying to go very slow for this initial session. So now tell me, are you clear about at least whatever we have covered until now? There is a question, why are we splitting available bits? So that is how IP addresses are defined because we have to reach that place, right? So let me give a example from real world. So if you can just quickly type the country from where you are participating, I can make this example a little more interesting. So can you quickly type the countries from which you are participating? Okay, we have Malaysia, we have US, we have Singapore, we have India, we have Canada. If I want to send a post to any of you, I'll have a complete address, right? Assuming you are staying in an apartment, I have your apartment number, I have your apartment address, and I have your city, state, country. I will have all of these things, right? So all of these things together makes up your address. Similarly, IP address is all of these things. So some of the parts of the IP address are used to identify which network you are part of. And some of the parts of the IP address are used to identify which subnetwork you are part of. In case of physical address, it is mostly a standard structure on the splitting. What part constitute a country, state, city, apartment, and within that apartment number, it is almost a fixed structure. But in case of IP addresses, we can decide. We can decide using the CIDR notation. For example, if we say 26, how many bits are used for identification? 26. And how many bits are used for actually allocating machines within that network? 6, right? So you need to identify the network and then you need to find that machine within that network. Clear? If you are doing within a lab and somebody is doing something bad, so you will need to find that somebody, right? For that, so first you have to find the lab. So that will be so these many bits will be used for that, and from within the lab, each individual machines will have its own IP address. So why we are splitting available bits? It's clear, right? So anybody, any doubts? Good. So everybody are clear about concepts until now. So there is a question: what is the equivalent of 6? So here, if you want to calculate the equivalent of 6 in binary, it is not very difficult to calculate. But in our case, when working with IP addresses, that is of no use. Here, the important thing is you have 6 bits available to play around. So that means what is the minimum? It is 1, 2, 3, 4, 5, 6. And what is the maximum? It is 1, 2, 3, 4, 5, 6. And how do you calculate this maximum? You do 2 raised to 6. And this corresponding to this, it will be 2 raised to 6 minus 1, because we start with 0. Clear? Okay, good. You understand what a virtual network is, right? We can call it as a VNet. Virtual network is an isolated network on cloud, and we can allocate a range of IP addresses to it. And any device within this virtual network can have only IP addresses belonging to this range. In Azure cloud or any cloud, we can also create other virtual networks. So since these are private IP addresses, nobody is going to stop us from using that same IP address for other virtual networks also. But if you want to connect these virtual networks together, connecting is module 5. These connections are called as VNet peering. In case if you need to peer these networks together, then you cannot reuse the IP addresses. The combination should have unique IP addresses. But if you are not going to peer, then it is perfectly fine to have same range repeated across different virtual networks. But when you create it, Azure Cloud will give you a warning that, okay, there could be overlap and all of those things. We'll see them when we see these things practically. So a virtual network has a range of IP addresses, and then we can create sub networks within this virtual network. So imagine that I have a virtual network here, VNet1. Why would I create sub networks? S1, S2, S3, S4. Why would I create? Can you tell me some advantages of creating sub networks within a virtual network? I'll ask many questions, and if you don't know the answer, all you have to do is type N. Okay, we have answers like maybe a department specific assignment for creating access boundaries, divide subnet to manage security. So one common architecture I will explain. Imagine we have a web application. So what are the different tiers of a web application? You will have a web tier, right? So you use some framework based out of HTML, JavaScript, CSS, etc. Right? And then you'll have some middleware also, maybe using Java, C Sharp, etc. So for simplicity, let us consider this as a single web module. And then we have a database, maybe a database specific to Azure, like Azure SQL or Oracle or SQL Server or some database. And I am a person from internet. I'm a user, end user. So do I need to access web server or database or both as a end user? Do I need to access the web server or database server or both? Yes, only web server, right? So that is where you can have subnets. So say we can have a subnet for web server subnet, and so this subnet will have access from internet, and we can have a database server subnet. So this database server subnet will not have any access from the internet, but it will only have access from the web server. Clear until now? So if I am working from home or even from my company, because cloud is not within your company also, right? It is somewhere on the data servers of Amazon or Azure or Google, right? Or any other cloud provider. So if I am a database admin and I want to make some updates to this database server subnet, can I log into this database server through the internet? Yes or no? So how will this DB admin log into this server? For that, we have a concept called as Bastion host or Jump host or Jump server. So different people call it differently. The idea is that in our VNet, we'll have our web subnet, we'll have our DB subnet. We can also have a Bastion subnet and have a machine within it. So you basically, as a DB admin, you log into this Bastion machine. So this Bastion machine is within the virtual network, right? So from Bastion machine, you will be able to access the DB server. So you can create your own Bastion host or Jump server. But most of the cloud providers, such as Azure Cloud, provide you that as a service or a feature. So you can create a Bastion host within an Azure virtual network just by a few clicks. Clear until now? So by default, from within a virtual network, all the machines, even though you are part of different subnets, you will be able to access each other. That access can also be restricted using something called as network security groups, NSG. We'll see all of these things in much detail. So there is a question if CSP not providing Bastion subnet. So what do you mean by CSP here? So CSP has a very specific meaning within Microsoft world. So yeah, you are just mentioning a cloud service provider like Amazon, right? Within Microsoft Azure ecosystem, the CSP is a reseller. So for example, Trainso is a Microsoft CSP provider or a reseller. So people can buy Azure cloud services through Trainso. Okay, so let us keep that aside. So now you are saying, okay, if cloud provider is not providing Bastion host, it will be Bastion host, and for that Bastion host, a Bastion subnet will be also created. So if you are not getting a Bastion host or a Bastion subnet, you can create it by your own. Within the 104 course, we learn about creating virtual network, creating subnet, creating virtual machines. Just these three knowledge along with knowledge of this NSG can help you create a Bastion host and Bastion subnet on your own. Basically, what you will do, you will create a subnet, you will add a virtual machine, and you will configure security so that this DB admin can log into that virtual machine, and from that, he should be able to log into this DB server. You can do it on your own. It's perfectly fine. Did I answer your question? Okay. So, any doubts until now? Virtual machines, subnets. So, there is a question what if there are multiple DB servers, DB1, DB2, DB3, and if you want to allow end user to access only DB1 via jump host, how that is typically configured. So, the jump host or Bastion host that is created by Azure Cloud, it is per virtual network. So, if you have three virtual networks, you need three different Bastion hosts. Okay, it is per virtual network, and once you are into that Bastion, you can use that Bastion to get access to any machines within that virtual network. And if you want specific permissions, then you can create jump hosts and configure it whatever way you want. So it is just a concept. So Azure Cloud provides you an easy way. You can just use that feature. But if you have specific requirements, you can configure your subnets, security, everything you can configure as per your need. You just create your own Bastion host and configure security accordingly. Clear? We will learn later that there are many different ways to group. Putting them into different subnets is just one way. Using NSGs, we can configure permissions. And there are also something called as application security groups, ASG. So we learn a lot of things going forward, but at least you have got the idea, right? Any day, yes, from all of you. Clear. Now let us come back to IP addresses. So imagine that I have given a IP address range of 10.0.0.0 slash 24. So this is the VNet. And as per my requirement, I need to have two subnets with equal size. So tell me if I have a subnet with NID as slash 24. And my goal is to make sure I divide it into two equal subnets. What will be the slash part? After slash, what values I can expect? When you work with subnets, you will have these kind of problems, right? What is 2 raised to 0? 2 raised to 0 is 1. What is 2 raised to 1? 2. What is 2 raised to 2? 4. And what is 2 raised to 3? What is 2 raised to 3? 2 raised to 3 means 2 into 2 into 2, which is equal to 8. So here, the raised to part is the HID bits, right? Raised parts are the HID bits. And what is my goal here? Can you see a logic here? I have something like 8 here, and I need to get the half of it. Two equal parts means half, right? So if I need to get the half of it, all I have to do is reduce 1 from the power. So the half of 2 raised to 3 is 2 raised to 2. Half of 2 raised to 2 is 2 raised to 1. You understood? That is how the power work, right? So we went from 0 to bigger numbers, but the opposite is also true, right? So when you go up, it will be double, double, double. When you go down, it will be half, half, half. So let us come back to our problem. So we have slash 24. So first step is converting it into HID bits. So slash 24 means it will be NID, right? How many HID bits will be there in case of slash 24? 8. Good. You don't have to actually calculate the numbers now. Just talk based on 2 to the power of thing. Okay, so now we have 2 to the power of 8 systems or IP addresses, right? So these are HID bits. So 2 to the power of HID bits is the number of IP addresses. So if I want to make it half, what I have to do? I have to just reduce minus 1 here. It will be 2 to the power of 7. So now in the answer, 7 will be the number of HID bits. When we define IP addresses, we have to specify the NID bits, right? So how do I convert this 7 to 7 back to NID bits? All I have to do is total is 32, right? 32 minus 7 equal mathematics. I will not teach. 32 minus 7. Everybody, it is 25, right? So the answer will be slash 25. There will be 2 slash 25 subnets. Clear? There are many calculators available online also for these. But if you really understand these concepts, that will be really good for 104 exam. Nobody is going to ask you about all of these things. But maybe once after that, if you do AZ 700, AZ 305 and go for a core networking interview, there you might have to know all of those things. But from my perspective, Don't think about interviews or don't think about certification. Whenever you learn something, you learn it well, understand it 100%. And if you can't understand it, ask doubts until it is clear. So clear until now? So there is a question how 2 raised to 8 minus 1 came. So that is why I showed this thing. So here 2 raised to 3 is 8, 2 raised to 2 is 4. So if I want to get the half of this number, what I have to do? I have to just minus 1 from this power. So 2 raised to 3 minus 1 is 2. 2 raised to 2. That is the half. 2 raised to 2 is 4. 2 raised to 3 is 8. 2 raised to 4 is, what is 2 raised to 4? 16. So if you want to go back, if you want to double, just add 1 to the power. If you want to make it into half, just remove 1 from the power. Clear? Our goal was to make it half, right? So we had a virtual network. We wanted to divide it into 2 equal subnets. 2 equal subnets means half of it. 2 halves. Clear? Everybody, please confirm. Okay, good. Okay, so now I will give a quick problem. I have an IP address range 192.168.0.0/24. I want you to divide it into 3 subnets. So before that, how many IP addresses are here? Quickly tell me how many IP addresses are here. How many IP addresses are here in this range? You can just mention the power format. How many IP addresses are there? It is /24. So /24 is NID bits. NID equal to 24. So what is HID? It is 32 minus 24 equal 8. And so how many IP addresses? It will be 2 to the power of 8. So this part you read it or write it few times so that it is clear for you. It is very simple. 2 steps. 2 to the power of 8. What is 2 to the power of 8? That is 256. Okay, so now in this range, I have 256 IP addresses. I want you to divide it into 3 subnets. First subnet should have 64 IP addresses. Second should again have 64 IP addresses. Third should have 128 IP addresses. So the sum is 256. Just give a try. After this, we will go to Azure Cloud portal. I need the first IP address within that range. So first IP address will be definitely 192.168.0.0, right? The first IP address in this is 192.168.0.0. When you create subnet, you cannot simply put the /25 or /26. You have to provide the complete range or complete CIDR format. Then only we can go and create virtual network and subnets and all of those things, right? Okay, it is almost there, but you are missing out on the slash part, because subnets, when you define subnets on Azure Cloud Portal or any portal, you need to specify the addresses in the CIDR format. So if you do not specify any slash, it will be assumed that it will be /32. /32 means how many IP addresses will be there in a CIDR format with /32? Quickly tell me. How many IP addresses will be there in a CIDR format with the /32? So 32 minus 32 equal to 0. And 2 raised to 0 equal to 1. It's all simple mathematics. So that is why I gave this table here. 2 raised to 0 equal to 1, 2 raised to 1 equal to 2. You just understand the concept and everything will come into its place. Okay, so yeah, we have answers. We have 192.168.0.0/26 is the first one. So /26, you assume you understood. So first you divide, when you divide /24 into 2, it will become two 25s. And again, once you divide one of those /25 into 2, it will become /26. If you divide again, it will become 27, then 28, then 29. Just keep in mind, whenever you are dividing a range into exact two halves, you just add one to the slash part. /26. /26 means how many IP addresses will be there. So this is the first one. 192.168.0.0/26 is the first subnet. So what is the first and last IP address within this subnet? How many IP addresses are possible? You tell me that first. It will be easy to calculate. How many IP addresses are possible? So the same formula, NID equal to 26, HID equal to 32 minus 26 equal to, what is 36 minus 26? 6, and 2 raised to 6 equal to 64. So that is clear, right? Same three steps. So if you have 64 available IP address, what is the first one and what is the last one? We learned based on 255, right? Similarly here. So what is the first one and what is the last one? First one is 0 and last one is 63. Okay. So the range will be 192.168.0.0 to 198.168.0.63. So this will be the first subnet. So what will be the starting point of a second subnet? What will be the starting IP of second subnet? So we have utilized until 63. So the starting will be 64, right? It will be 192.168.0.64/26. So here also, what will be the last one here? 192.168 dot first one will be dot 64. Last will be dot, yes, 127. Some people said 125. So what is 63 plus 64? 7, 12, 127. So do not worry about usable and all here. So this is pure mathematics. So all those usable things will differ from cloud to cloud. So what will be the starting IP address of the third one? Okay, it is 192.168.0.128 and slash 25. So it will have 128 IP addresses. So are you clear about IP addresses? So these things, if you simply watch, you can never become 100% clear. You have to practice it. Okay, there is lot more to IP addresses. If interested, I can take an advanced IP address class where we can go much deeper into all of these things. But for our virtual networking session or working with virtual networks, this is good enough. So tell me, are you clear about the IP address concepts? And all the things that we discussed until now today. Even though I had given IP address as a prerequisite, I was sure that I needed to discuss some of it. Most of the AZ104 sessions simply jump into creating a virtual network. And then randomly you choose some subnets without understanding how these things actually work. So do you think this approach is better or focusing on Azure cloud alone is better? This will definitely take little bit more time, and you will also need to put some efforts from your side, but this will make you a real Azure cloud engineers. So that is what even forums here promises, right? Real Azure cloud engineers, not just certified engineers. Okay. So as long as you are okay with a little bit of extra time for these kind of discussions, I am perfectly fine doing this. But if you think like, okay, my goal is only certification, then I need to speed up, then we can change the format also. Okay, so let me go back to Azure Cloud Portal. So creating virtual networks are very straightforward. I would just search for virtual networks and create a virtual network and a name. You can configure, you can create a bastion now itself if you want. So there are a lot of other networking and security concepts. Some of them we will learn as part of 104, and some of them we will learn from the AZ 700 syllabus. But today is about IP address. So IP address. So we have provided /16, and Azure has provided a default subnet here. So maybe if you are practicing with virtual machines, maybe you can just go ahead and create it. Or if you have some specific needs, we can specify our own. So, and then subnets also, maybe if you want, we can delete, and then we can add subnet. So starting address and size. So whatever we saw, right? So in our case, we put /26, right, for the first subnet. So here things are much easier because Azure will show everything here. So here the range, whatever we calculated, right? So whatever we calculated, it is here, and then you can add. So the next one, if I want to add, you can add, and then okay, size is /26, right? So if it is 26, then it is 64, the same that we calculated in our discussion, right? Add. And third one, so third one, it was 125. Sorry, third one, it was /25. So the starting is 128, and this is the range. We used 192 dot, but just look at the last ones. So these are the subnets that we created in the lab discussion also, right? Clear? So once you understand the concepts, this will be super clear, because as soon as you select itself, Azure will show you first and last range and all. And see, and click on create. Okay, so we have our virtual network. And if you want to create a resource such as a virtual machine, this is not a virtual machine session, so I'm not going to explain all of these options, but I've explained this in the prerequisite sessions. So let us keep it simple. Okay, so again, we are not going to use any of these. Doesn't matter. So our focus is here. So if you select VNet 1, then these are the three subnets we created, right? So assume that we selected default 2, and then we can create a public IP address if you want from here itself, or you can create one. So if you go into so here we are creating public IP address from here itself, or you can search for public IP addresses, and you can create a public IP address from here. Or if you want to have some consistency for your application, then you can search for public IP address prefix, and then create a prefix, and then allocate from that prefix. Okay, we have labs for all of these things. I'll go through it after this. So in one of the ways, you have to create a public IP address in case if you want a public IP address. So if you don't need, don't create. Okay, and then maybe focus on other things. So some of these things we will learn, because this is not a virtual machine session. I'm not going to focus on virtual machine, but I want to show you how IP addresses will be created. So now, so here important thing is we have selected the second subnet, right? Even from the prerequisite videos or any other sessions, if you have doubt, you can ask me post session every day. I stay back until all of your doubts, queries about the program, about any topic you want to discuss. Just learn. Okay, so it's a simple one. So if we go to resource, we have not allocated any public IP, so it will not have public IP. But it has a private IP, right? So this private IP is within the range, right? So we calculated a range, right? So this private IP is from that range. So what was the range of the second subnet? It was 64 to 127, right? And this is within that range, right? And the subnet. So clear? Clear until now? And IP address, public IP address you can create. And if public IP address is there, then you can have a DNS name also. So all the DNS names, like there are a lot of concepts with respect to DNS that we will cover in next class. But from an IP address perspective, are you clear? So let me quickly take you through our labs also. So creating an Azure virtual network. So we have created, but you can follow these steps to easily create. Add some extra information also you can read through. So do not just stop after the CP. Adding subnet if you want to add later. Creating a public IP address. It's all straightforward. So you go to public IP address, create, You can select if you want to go with IPv4 or 6, standard or basic, regional or global. Okay, and then you can create one. So either or you can create a prefix. So first you have to create a prefix. So prefix, you will mention, okay, prefix, what is the prefix size? So now when you see these things, you will understand, right? What is /31, what is /32. So you select a prefix and then you get that prefix. And then once you get that prefix, you create an IP address from that prefix range. You select that prefix and then you create one from that IP address, and then you can select that IP when you create a virtual network. So if you have some firewall rules based on IP addresses and all, this can help. So whatever IP addresses you will be allocating to your virtual machines will have a pattern. Otherwise, your public IP addresses won't have a pattern, but private IP addresses you saw, right? It is always from that list. But public IP addresses, if you want a pattern, then you will have to first create a prefix and then create a IP address from that prefix and then assign that IP address to your virtual machine. Okay. So IP addresses, if you understand it, it's a very easy and straightforward concept. I thought rather than simply jump into IP address, we understand IP addresses, and we even touched upon some core Azure concepts also, so that anybody who attend any of the sessions that starts from a new topic will not be left behind. Okay, so we had people who are completely new to Azure Cloud, had some knowledge with Azure Cloud, completely new to IP addresses, people with some knowledge of IP addresses. So now you are clear about all the concepts, right? At the end of the session, IP addresses, subnets, why do we need it? How to design IP address range for a VNet or subnet, private versus public. From next class, we will focus on doing things within Azure Cloud, like DNS, like VNet peering, and all the other concepts that are part of syllabus. And if you have any suggestions, you have my LinkedIn profile, you have my mobile number. If you are part of the Forum CA program, you just have to ask me. We have a dedicated team from Tuesday until Saturday. It is not like you have to wait for me also. If I am busy, the team will be there to help you with any doubts with respect to any labs. So the only thing that is preventing you from becoming a cloud expert is you. Okay, so bye bye for now, and see you all in next class. Assuming there are no more questions or doubts, and just learn, practice, dedicate these 4 months to becoming a good, real Azure cloud engineer. Okay. So shall we wind up? Okay. So bye bye for now, and see you all in next class.